Hi friends, welcome to Easy to Learn channel. In this video I am going to explain about evaluation of mean square error. Previous video we have seen the analogy between the vectors and signals. So here we have to find out the minimum mean square error. So how to find out that minimum mean square error is nothing but average or square of error function that is represented as fe of t, which is called a mean square error. So in order to find out this value of E, when optimum value of coefficients, here optimum values are nothing but component values. So we have to take in n component values that is represented as C1, C2 and so on up to Cn. So we have to choose these component values. Now, so the equation for error function minimum mean square is E is equal to 1 by t2 minus t1 integral t1 to t2 fe square of t into dt. So we already know error function fe of t. So if you see in signals, we have find out the orthogonality of two signals. So in that two signals, we have seen fe of t, that is error signal. So here error signal is equal to f of t minus summation r is equal to 1 to n cr gr of t whole square into dt. So here r is equal to 1 to n. So now fe square of t. Fe of t is equal to what? F of t minus summation r is equal to 1 to n cr gr of t into dt. Here this summation represents the number of component values. Here we are taking n component values. That's why here the summation values are starting from r is equal to 1 to n. Now here, so this can be represented as a minus b whole square. That is nothing but integral t1 to t2 s square of t dt plus this one whole square. That is nothing but summation r is equal to 1 to n cr square gr square of t into dt minus 2ab. 2 into summation r is equal to 1 to n cr summation t1 to t2 f of t gr of t into dt. So we have to write this equation in the form of a minus b whole square. Now cr is nothing but the component value, r component values, that is equal to summation t1 to t2 f of t gr of t dt divided by integral t1 to t2 gr square of t into dt. Now if you find out here, so this cr which is multiplied with gr of t into dt is equal to summation t1 to t2 f of t gr of t into dt. So here cr g2, this equation we have to take it as kr. For simplification we have to take this equation as kr. Kr is equal to summation t1 to t2 f of t gr of t into dt. Now here kr, in this equation what is kr? Summation t1 to t2 j r square of t into dt, right? So now here for this component value equations, if you substitute, that means E is equal to 1 by t2 minus t1 f square of t dt plus, so in previous equation, see in this equation, so what is this value? Kr. So we have already seen, for simplification, integral t1 to t2 gr square of t into dt, which can be written as kr. So how to write this one? Summation r is equal to 1 to n cr square kr minus, now this one, 2 summation r is equal to 1 to n cr summation t1 to t2 f of t gr of t. So here f of t gr of t is nothing but what? Cr integration of gr square of t into dt. Now substitute in place of this, you have to substitute this one. Okay. Now again, what is gr square of t into dt? Kr. So in previous equation, in this equation we have to substitute CR KR, right? So that is nothing but 2 into R is equal to 1, summation R is equal to 1 to n CR square into KR. 1 by T2 minus T1 integral T1 to T2 f square of t dt minus, so in this it is, this value is a minus this value is a, that is a minus 2a is what? A. So we can get this equation. Now expand this one. If you expand this one means you get c1 square k1 plus c2 square k2 plus and so on cn square kn. So here r values are from 1 to n. Last value is 1. So this is the equation for minimum mean square error. Thank you.